Welcome back again. Today's lesson is on a big weather maker. These are called low pressure cyclones. And understanding low pressure cyclones is a very important part of understanding how weather systems affect us in the mid-latitudes, like, New York State. First of all, let's read off this little paragraph. Kind of tells the story of what they are. Low pressure cyclones often result where a cold front meets the back of a warm front. On a weather map, it often looks like the profile of an ocean wave and is often called a wave cyclone. At least that's the way I learned it a long time ago. The fast-moving cold air pushes up the warm air, pushes it up and out of the way, and the warm, humid air then rises. You guys know what happens next. Expands and cools to that magic dew point, forming lots of clouds and rain. Cyclones rotate counterclockwise in the northern hemisphere. Remember the Coriolis effect. And clockwise in the southern hemisphere. Anticyclones, these are the arch enemies of cyclones. These are actually the good guys in my opinion. They occur around high pressure centers, so there's an H in the middle. They contain cool air that sinks, compresses, and if you remember that orographic effect again, warms above the dew point. This evaporates clouds, creating clear skies. Anticyclones rotate the opposite way of low pressure cyclones. They rotate clockwise in the northern hemisphere and of course counterclockwise in the southern hemisphere. So this Coriolis effect really does play a role in cyclones and anticyclones. All right, let's draw a top view of a low pressure cyclone. And let's start out with a red L right in the middle. And the air is going to want to travel towards the center of the low. And so if we start out with some air right here, it wants to go towards that low, but in the northern hemisphere, that air is deflected slightly to the right because of the Coriolis force. And so it's going to want to go this way, but it's going to really end up over here. And then from this point, it's going to want to go towards the low there, straight towards it, but it's going to end up a little bit to the right. So it's going to end up there. And this keeps happening. It's going to want to straight towards the low, end up a little to the right, but eventually it makes its way into the low. So we have an overall effect kind of like that. Now this is going to happen with air coming in from all directions, forming this cyclonic motion in the counterclockwise direction. And so we can sum it up with, first of all, the air rotates counterclockwise. Second, it's converging upon the middle. And because it's low pressure, it's warmer, more moist air, and it's going to rise, expand, and cool. It's going to create cloudy, stormy weather. Remember, this air is light compared to cold air, so it's going to be rising as it's rotating inwards towards the low. And I know you know that winds bend to the right in the northern hemisphere, but because of the fact that this rotation is occurring, it's actually getting drawn in and curving in a leftward direction. It's kind of confusing until you remember how I showed you how that occurs. Okay, top view with warm and cold fronts. Now, this is what you really don't see on a weather map. You don't see this. On a weather map in the 6 o'clock news, you probably see something more like this. A low with the center of it right there. And you'll see perhaps a warm front curving like that because it's moving in this direction. And then perhaps you'll see a cold front moving in this direction. And usually, whoops, that's incorrect. Usually behind the cold front, you'll see perhaps something like continental polar air mass, maybe not in the 6 o'clock news, but there'll be cold air back here, cool at least, and drier. And perhaps a maritime tropical air mass here, more moist and warm. Often, these air masses are coming up out of the Gulf of Mexico, the ones that affect us in New York. And the whole thing is rotating just like that upper picture. Everything's coming in and to the left. Let me switch colors with this instead of using the same colors as I'm using now. Everything's kind of coming like this. Like that. And as this occurs, we have, of course, all the weather associated with cold fronts. We have perhaps thunderstorms here, or perhaps violent weather. And we have all the weather associated with warm fronts, which usually the precipitation occurs out here in front of the warm front. So we have perhaps, some clouds and rain along the front of the warm front, and some clouds and rain right at the cold front. Not necessarily, but that's common. And this whole thing, this whole diagram is moving with the prevailing winds in the United States, generally speaking, towards the northeast from the southwest, following our prevailing southwesterly winds. So it's a little confusing because you got to put all these pieces together, but these are the big weather makers in the mid-latitudes, which is where we live. And this is kind of summing up what I showed you here. I don't think this is going to work. Oh, maybe it will. Oh, here we go. This is the not working too well. It's a picture, not an applet. All right, so I'm going to back out of that and forget about this, but we'll just kind of sum it up as saying that the air is going to go like this. Here, 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 counterclockwise rotation overall towards the center. And this whole thing, there's our cold front, warm front, the whole thing's moving towards the northeast. We have our maritime tropical air here once again, perhaps our continental colder air right there. That's moving that direction, moving this direction. You get the idea. I don't want to show this 2 times in a row. But you have to remember back to your fronts, your cold fronts, warm fronts, and perhaps your occluded fronts too, because that's going to tell you what happens at each of these locations. Okay, the actual names of the isolines, I think you guys remember, since these have numbers like this with units in millibars. Remember, these are isobars. And you'll often see these circular isobars around the center of our low pressure system right there. There's the low. And the lowest air pressure is in the middle, 996 here, and it gets higher as you go out. And once again, there's our maritime tropical and our continental polar. And you can see the front, the cold front's moving this way, warm front's moving this way. And you can actually start looking at this map and start making forecasts for each of these cities. For instance, Plattsburgh. Plattsburgh is out in front of this warm front. So you might have some rain or some type of precipitation in the near future because it's raining in front of, or precipitating at least, in front of warm fronts. Whereas Rochester is right at a cold front. It could be actually raining there, brief, heavy rain right at Rochester now. We don't know that because we don't have any more weather data. And Buffalo could have just had that heavy, brief rain, and now it's cooling down. It's clearing out the skies as that high pressure air moves in, that dry air from Canada, continental polar air. Binghamton's kind of in the center of the maritime tropical air mass. This could be like a warmer air here, more moist and humid, but that will change as this cold front wraps around and eventually passes over Binghamton. And just a quick review, once again, maritime tropical air masses in New York State usually originate in the Gulf of Mexico, and the continental polar air masses come down from Canada, central Canada. Those are their source regions, if you remember that term. Okay, draw the front symbols on the map below. I think we already know this. You can see there, cold front. This stuff becomes repetitive after a while. Warm front, it does matter which side you put these on. And there's our side view. You can see we have our cold air mass here, moving this direction. We have our warm air mass stuck in the middle here, moving to the right. And of course, rising up, there's our warm front with our cirrus clouds, stratus clouds, nimbostratus clouds, raining in front of warm fronts and raining right at cold fronts. And these places all correspond. Letter C or A, B, C, D, and E all match up. You can see that. There's your maritime tropical, your continental polar, and note how the lettered locations line up. And we can throw them right on there. A and B, C, D, and F. And this is a really good way to look at this, because we have on the top part of our diagram the top view, which is what you'd see on the 6 o'clock news, maybe not as detailed as that. And what's really cool is to see this side view and the fact that it's over a large scale here, large scale. But the side view really kind of puts it into perspective. All right. So to sum it up, anticyclones, clockwise spin. Actually, not summing it up. We're moving right on to a different one, though. This is anticyclone. Yeah, high pressure. And let's draw one of these. Now, anticyclones are kind of like the opposite of cyclones. Instead of low pressure, they are high pressure. Hopefully you guys can see the high there. I'll darken it in. And of course, air moves away from high pressure, and it bends to the right in the northern hemisphere because of the Coriolis force. And so because of this, it has an opposite rotation. Instead of counterclockwise, you can see it's rotating overall clockwise. And it is diverging. It is moving away from the high. That's what divergent means. And this air is cool, it's heavy, it's sinking. And as it sinks, remember the song we learned earlier on last week, as it sinks, it compresses. And that compression causes adiabatic warming. And so it's warming up. The air is going to go above the dew point most likely, and that's going to evaporate any kind of clouds that you see. And so that's why you have fair weather found at these anticyclones. And that's showing the same thing there. You can draw the air moving away, bending to the right, and you get your cyclonic motion outwards. You don't see these things on weather maps, with lots of clouds, because the clouds are all evaporating away. And that's it as far as cyclones and anticyclones go. We're obviously going to practice some of this stuff. I have some activities lined up for you. But for now, you can put your notes away.